Okay, so this is the lesson on volume of a prism. This is 15.2 for the foundation class. So before we get started, let's talk about what a prism is. So a prism is a 3D shape with a consistent cross-section throughout. So in this cylinder, you can see that this circle, that is this front face, is the same throughout. Same for this square in this cube. This front face is projected throughout the shape, and this rectangle here is the same throughout this cuboid. These three are all prisms. Cross section of a circle, cross section of a square, cross section of a rectangle. Right then, so to find the volume of these shapes, so we're going to find the space that these shapes fill, we're going to use this formula. So volume of a prism is equal to the area of our cross section multiplied by the length of our prism. Okay, so throughout this lesson, I'm going to condense this down to area of CS multiplied by our length, okay, L. So for our basics, I thought we would have a example. So this one does not appear in your textbook, okay? So here we have a cuboid. A cuboid is a prism with our cross section appearing throughout the shape. So our cross section this time is this rectangle. So if I just draw in this rectangle, and we'll talk about the area of this. The area of this front face, which is our cross section. So we've got 2 centimeters, so that's this face here. 2 centimeters, 3 centimeters, and the area of a rectangle is base times height. So we've got 3 times 2, which is 3 times 2 is 6, and we're dealing with area, so that's centimeters squared. Right, so to find the volume of this prism, we're going to do our cross section, so the area of CS multiplied by our length. Okay, the area of our cross section we've just figured out. So our cross section is this rectangle with an area of 6 centimeters squared, and our length is how much it is projected back by. So the distance that that side is projected, that face is projected back by. So our length is 10. Therefore, our volume for this one is 60 centimeters, and now this time it is cubed because we are dealing with volume. For question 1 in the textbook you'll find on Caboodle, you will see that we've got a really unusual shape for this one. So we've got an L shape for our cross section. This L shape is projected all the way back throughout our shape, so this is in fact a prism. So we're going to be using exactly the same formula for finding the volume. Okay, so this being our shape, let's think about our cross section, because we're going to have to find the area of this, since that's our first step of finding the volume. So we know that from this here, we know that we can say that this has got 5 centimeters across the bottom there. Okay, we know that this side here is exactly the same length as this side there. So this here is 2 centimeters. Okay, we then have that this is 4 centimeters high, but if we put 4 centimeters here, we can't find out the 2 separate areas of our 2 different rectangles. Okay, so we know that this being a rectangle, that means that these two are the same. So this is 2 centimeters. And since this is 4 centimeters high, we know that we've got 2 centimeters left here. Okay, again, we know that this side here is exactly the same length as this one. So that means that this is 2 centimeters here. Okay. Right, so Moving on to cuboid 2. Cuboid A, which is your orange one. Okay, so this is the one on the top. So we have our side lengths. So from here we can see that that's 2 centimeters. This is 2 centimeters. And we know that this bit here is 2 centimeters. So that's the same as this side. So that's 2 centimeters as well. We know that our length of our whole shape is 10 centimeters. So that's going to stay the same on that one. Nothing to do with that. Okay. On here, this is our cross section. So a cross section on this one is that whole square on that side. So we've got 2 centimeters and 2 centimeters. So the area of our square is base times height, which is 2 times 2, which is 4 centimeters, and squared because we're dealing with area. Therefore, the volume of this bit, so the volume of A, we know to be the area of our cross section multiplied by our length. Okay. The area of our cross section is here. That is 4 centimeters squared, and then we're going to multiply that by our length, which is 10. Okay, so that face is projected by, that cross section is projected back by is 10 centimeters, so we multiply it by 10. Therefore, the volume of A, so the top of our compound shape here, is 40 centimeters cubed because we're dealing with volume. We then have part B to do. So in exactly the same way, we know that our side length has to be 2 centimeters. So we've got 2 centimeters, 5 centimeters is the bottom, and then we're projecting back by 10. So that's our length. So for our front face, we know that we have 5 centimeters here. We have 2 centimeters there. So we can find the area. So the area of this rectangle is base times height, which is 5 multiplied by 2, which is 10 centimeters squared. The volume of B is equal to the area of the cross section multiplied by our length. So the area of our cross section is 10 multiplied by 10, because that is our length. That's projected back by. So we've got 100 centimeters cubed. So we're dealing with volume still. Okay, so our total volume then, we're not done yet. So the total volume, answer the question. Total volume of this shape is equal to volume of A plus the volume of B, since they're stuck together. So we have 40 plus 100. So our answer is 140 centimeters cubed. And that's your final answer there. Example 2 in the textbook, the prism looks slightly different. In this one, we have a triangular cross-section as opposed to the square or rectangle ones we've seen in example 1. So this here is our cross-section for this one. This triangle is why it is a triangular prism. This triangular face is projected backwards throughout the shape. This here is our triangle. This is the cross section. So the area of this is half base times height, much like any other triangle. So half multiplied by 4 multiplied by 2 to the base and our height. So that's from the base to the top. So our perpendicular height is 2. Okay. So our answer here has got to be half times 4 times 2. Half times 4 is 2. Times 2 is 4 meters squared. So we're dealing with meters in this one. Right, so the volume of this prism is the area of cross section multiplied by the length. The area of the cross section we've just seen is 4, and we're going to multiply that by our length, which is 8. So that face is projected back by 8 meters, which is going to give you 32. Now we're dealing with meters again, and it is a volume, so that's meters cubed. In example 3, we have a cylinder. So cylinder is a prism with a cross section that is this circle on the top. Okay, so this circle here is projected all the way down this shape, and it's the same circle on this end and that end. So that's our cross section. Okay. So this is our cross section. We need to find the area of that. So the area of a circle is pi r squared. Okay, you will have seen that in earlier lessons. So pi multiplied by our radius, which is 3, and then we're going to square that. So pi multiplied by 3 squared. On your calculator, you will see you have a pi button down here. Okay, so you do pi, so shift pi multiplied by 3 squared is equal to 9 pi s to d, turn into a decimal. Our answer is going to be 28.2743 centimeters squared, because we're dealing with area. Right then, so the volume is the area of the cross section multiplied by our length, which we've used already. So the area of the cross section is 28.2743 multiplied by our length. This time, that's the amount it's projected back by. So we're projecting this circle all the way back by there, bit down there, which is 7. So our answer is going to be this multiplied by 7, which is 63 pi, or 197.92. And that is going to be centimeters cubed, since we're dealing with volume. For this question, you'll see in the exercise book that it goes into surface area. Don't worry about this for now. This will be covered in a later chapter, I believe 15.3.